Welcome to Qt Widgets and more. In today's episode, I'll go back into the land of template metaprogramming. More specifically, I'll talk about SFINAE, I believe you would say it. Substitution failure is not an error. The reason why I'm doing all of this is that I implemented a new algorithm in KDAlgorithms, namely sort by, which was anything but as trivial as I thought it would be. So KDAlgorithm is a utility that wraps the standard template library, or at least part of it, and for my needs at least, makes it somewhat easier to work with. It's, and that's the key thing here, is supporting C++ 14 and above. So there's a lot of things that came around in C++ 17 that would have made my attempt here much easier, namely, if nothing else, that C++ 17 have stood invoke in it. I'll talk a bit about what that is in a second. But C++ 14 doesn't, so I needed to implement stood invoke myself. So have a look at the code on the screen right now. It's a simple vector of things that I sort. And just let's get over with it. My foo here, it is nothing but a simple struct that has a few methods in it, and it has some utilities for printing it out, something I'll do in this video here. The key thing is that my vector, I initialize it up here with some random data, and then I sort it, and I sort it in the C++ way of the standard template library by begin and end, and a method here that compares items. Obviously, in KDAlgorithms, there's already a KDAlgorithm sort that where you just give it v and the parameter here. But what I don't like about that is that when I looked at my code, well, first, when I got the idea, I looked through my code and I found that 95% of all the sorts that I did, where I needed to specify some parameter, I basically just validated or sorted on one of the properties in my structs that I wanted to show. So I thought, hey, I can do better. And this is what better looks like. If you look down here, sort by member variable, specifying the container that I want to sort, and a pointer to a member variable. And that's the syntax here. If you're a Qt user, you definitely know that syntax from your connect statements. It's the class and the member variable, and then the ampersand in front of it to specify that it's a pointer to a member variable. I also have this sort by member function, which again take the same things, the container and a function, and or a member function. You can see the member function here is just a regular function, while first and second was regular member variables. Let's look at the implementation of these two. It looks like this. It's a template, but don't get scared about that. That part is relatively easy. Template, the type name of the container, type name of the variable, and it takes a container and a variable as the parameters here. You might say, why is it not a const variable reference? Well, it's just a pointer, right? So then it calls stood sort on my container begin, container end. That's a regular sort I call here. And I give it the method to sort by as the parameter here in the method. That's where things get really hairy, because this is a lambda expression, as you can notice here. The lambda expression takes two variables, x and y, from the container and needs to compare them to tell whether one is less than the other. That's the less than sign you see here. And here is where it gets really, really complex, at least for me. I needed to look at this a few times to reiterate, what does dot star really mean? Well, what it says is that I have this object here, and I'm calling, or I'm accessing my way in to the instance variable here that I got in. And this variable is not just the name of the variable, it's a pointer to member variable. See, the key thing is that we have exactly the same down here, more or less, except that here it says x dot star, and then parenthesis open, parenthesis close. And that's where I really wanted to not have two functions, one sort by member variable and one sort by member function. I wanted one, but there was this slight difference in syntax here. And that's what I set out to solve. Somewhere in my brain, I had a memory of something called invoke. I looked it up and I saw that invoke solves exactly that problem. So hallelujah. Unfortunately, invoke is only introduced in C++ 17. So I basically had to implement my own invoke. And that's what we'll be talking about in the rest of this episode. And I know that you guys don't believe me for good reason. I am, however, not kidding you this time. So let me just show you the code for the invoke case. It looks like this. Over here, we have sort, again, blah, 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 blah. And then invoke member, x, member, y. And I can call it down here either with second or with fraction. This was my member variable. This was my member function. And you can go to GitHub and get this code and run it to actually validate that it works. And it will print out the things sorted accordingly. Before I get really started with the details of the implementation, let's just take a step back and look at all the small building blocks we have in calling a pointer to a member, function, or variable. There actually is 2 times 2 different combinations of this stuff here. There's namely the pointer to member, variable, or function, and there is whether it's what I hold the object, whether I hold the object or I hold a pointer to the object. And the latter is important if I have a vector of pointers to, say, Qt Widgets. There I hold the pointer to the object. And fortunately, the syntax allows me to do that case also. So here is the code to look at. First, I have a pointer to a member variable. And this is the syntax here, int foo : pointer variable. And variable is the name of the pointer to the member variable. And here's the pointer to a member function. And the syntax is even more hideous. And yes, God knows, I would just have written auto function if I had to do this by real. But I just wanted to show off my awesome Googling skills because, of course, I couldn't remember this myself. Accessing the variable without going through the pointer to member stuff, that's what we see here. But that's not what I have. I want to have this function that takes the pointer to member, whatever, and as a parameter. So this is what it looks like. We saw that just before. I really just wanted to show my Google skills here. So this is my object foo up here, dot star to access the variable, dot star to access the function, and then calling the function. I need parentheses around this, otherwise the scoping rules would have function parentheses and it would complain about that. That took me a good hour to figure out what that error message was. And now I take the address of my that's my foo pointer g now, and you can see the syntax is exactly the same with the no parentheses and parentheses, but this time the dot is replaced with a minus greater than. That's your regular pointer dereference mechanism. And down here, I actually print them out with invoke. So you can see it's the same syntax, whether it's f or g, and whether it is the variable or the function. And into the stage is SFINAE. There's a link right here that points to a previous episode I did in the Qt Widgets and more series on exactly that technique. You might want to pause me now and watch that episode before we continue. Otherwise, if you have good memory or you know a bit of the technique, carry on. So if I can get your attention down to this code here at the bottom, sort by. See, now it's the same name, but here I give it the second, that's the variable, and here I give it the function. So how is that possible? Let's look at the sort by. So sort by calls sort, not surprising, with the container begin, container end, and it does this by implementing, hey, isn't that the code that you saw just before? Well, it is up to the point where it doesn't say std in front of the : So now it's not the std version, it's the global version, which is because that I have all these steps inside of a number of files that would be competing with the naming. So therefore they're all in anonymous namespace. That's what you see up here. Namespace, nothing, so colon invoke is the one that we have right up here. Invoke takes function and the object. It calls invoke helper, and invoke helper just gives the function and the objects to those, and then it calls stud is member function pointer function. So that's a function that I can go into my documentation and look at. There is a link right here now to the documentation for all of these different type traits inside of the C++ template library. And is member function tells whether this one here is a function. If you have a good memory or you just rewatched, you will know that this stuff here actually, well, let's go and look. It's a struct. So it's not as it would look like here. It looks like, yes, it's a Boolean, and you would be even more confused because stud false type up here, but it's a struct. And it boils down to that there's two different structs. One that is called false type and another that is called true type. No, they are not Booleans. They are as different as person from inventory. I'm just making up two different classes that have absolutely nothing to do with each other. And that's why this trick works. If, and this is at compile time that it will do this. It at compile time will call the invoke helper, the one that takes a true type and one that takes the false type. And depending on whether it is a member function. That's what we see down here. This one is a member function. This one is a member variable. If it's a member function, then we have the true type here, a member function, and then we'll call the dot asterisk parenthesis open parenthesis close. And down here, dot asterisk without the function call. That is a pretty nifty trick, and I re-recorded this, or not re-record, I recorded this episode here too, because this SFINAE trick is actually pretty useful, even in places where you do not do complex template programming like KDAlgorithms, or well, complex, that's for the eye of the beholder, but at least in not necessarily only template code. And yeah, have a look at this library of these is member function pointer and all the others. At this stage, you might say, wait a minute, Jesper, shouldn't you be perfect forwarding and perfect returning and all of those things? And yes, I should. And there is also a link at the bottom of the description here that shows you to the exact code, the final production code in KDAlgorithms. I am implementing a simplified version for the explanation in this video. You might also say, Jesper, wasn't there something about the issue of pointer versus instance? And yes, there is. And that is what I'll show you now. It doesn't get much more complex because of that. I will just call stud is pointer to the object here to test whether it is a pointer or not at compile time. And you can see true function or true type, and there's two versions here with full types, and then the dot asterisk, and arrow. There's actually one more thing we can do to this code, namely, how about regular callables? So a lambda, for example, or a global function. And yes, let me just show you this right away over here. This time I can also, and see my test cases down here get longer and longer. I have a lambda here that does stuff with stuff. That's what it does. It takes the first and the second and multiply them together. And notice what this is used for is my sort by. So it will get two elements of my vector, and it will take the first element, multiply its first and second together, and take the second and multiply its first and second together, and then it will take these two results and compare them with operator less than, as we saw earlier. So sort by with this lambda expression should also work. And for that, I now test whether is member function pointer. No, is member. Come on. Member. What did I have before? Before I had the, see, that's where the documentation sometimes is member function pointer. So of course, yes. Is it a function pointer? Here I just test whether it's a member pointer at all. So a pointer to a variable or pointer to member function or pointer to member variable. Thank you very much. If it's not at all that, if it's not is member pointer, then I have this case down here where I just call f on my object. So I just call my function on that object given. And in that case, I don't need these two here. So I just have don't care. These will bind to anything and to any type and not be used in here. So that works both for std true and std false. And I simply don't care. Sometimes it's useful to go back and reiterate what you already know, just to refresh those brain cells. And that's exactly what I did here. Had I not been limited to C++ 14, I could have done without SFINAE. And let me show you the implementation in C++ 17, where I have const expression if, which makes things much easier. My invoke this time looks much simpler. No need for invoke helper, because I now use if const expression. And the idea with if const expression is that if this stuff here evaluates to true, then this code will be evaluated and the remaining of the code will simply not even be compiled for the type in question. See, it's instantiation of different types here for the invoke method. So I have invoke in my final binary, I have a number of invokes for different types. So if const expression is member pointer underscore v, so this takes the std : false type or std : true type and actually pulls the value out of that one, so the boolean out of this, so I can use it in regular if here. But the keyword is const expression. So if const expression, so at compile time, not at runtime, at compile time, I will test whether the function given here is a member function. And if it is, it will simply result in this code. But that also, let me just show some embarrassing things here. Whoops. See, that was embarrassing, but not the embarrassing thing I wanted to show. Just take this here and this one down here. I had that code. I thought, hey, I'll test whether, and then I have an early return and then continue on. But the problem, as we hopefully will see now when I try and compile it, f cannot be used as a member function since, yes, read all that stuff. And what you will come up to is that down here, I try to call sort by with a lambda. And see, given that there is not the else part here, this is at compile time. My compiler will say, okay, so yes, this one executed, but I do not have the else part. So all of this stuff down here is also attempted at being compiled. So my lambda expression, it tries to do one of these four. I can't remember which one it would end up with, but that obviously doesn't work. So we need to have them in here. But do compare this very simple one to the SFINAE. So thank you very much for those of you who implemented the if const expression in C++ 17. It's almost 20 minutes into this video, which means that you likely are not there anymore. So I'm sitting here talking all by myself. But if you're there, here is a bit of bonus material. Namely, we want to make our invoke even closer to the std invoke. And what is the difference between our and the std invoke? It is that the std invoke can take any number of parameters to the functions that you're about to call. And that smells very much like variable amount of arguments, and indeed it is. And it looks like this. So this is my C++ 7 version again. This time I need to specify a number of arguments here, and these arguments are templated, whatever that's called, on the args up here. So up here I say that I have my function, my object, and then a number, 0 or more arguments types, and this is given down here, 0 or more arguments type. And that's just the syntax here, type name ... args indicate. Args is now a parameter pack of these types, and well, it's a parameter pack type of the types there. And down here I have the actual parameter pack, namely args, which is the variable amount of arguments. And I just call that on. So you can see down here, if that's the version where it's not a member pointer, I call if with O, so that was the first parameter. And if there are more arguments, then they are added here. Similar args ... args ... and here's a special one. I need to assert if you're trying to call this one. This is the version, or this is the branch down here where you're trying to access the variable. And obviously, if you have a pointer to member variable, then you cannot have any additional parameters as you could if it was a pointer to member function. So I have a static assert down here where I test whether the size of, and again the syntax here is size of ... the args is equal to 0. If not, it will complain. And the final bit of this is going to C++ 14 and it's just applying all of this. It's almost like, hey, just go and read the code yourself, but let me just walk you through it. And we're back at the invoke helper here. It takes the variable amount of arguments in here. It is given on to the calls here, and we can see args ... args ... args, so on. Type name up here, and that's all cool. And the special case with what if it's a member, not a member function pointer, but therefore the false type. That's what we have here. There I'm calling onto a member variable, and see there is no args in here, so it would give me a substitution error that there was no good versions if I gave it a pointer to a member variable and tried to give it some variables in addition to that. Thank you very much to all of you that was hanging on for 20+ minutes of template meta programming. If nobody else, I know that Sebastian from KDAB was listening in here, was reviewing it while I was presenting it. Thank you to you, Sebastian, for watching it. And for those of you that is sitting there right on the edge of sending me an angry review with a thumbs down saying, hey Jesper, you forgot this and that, there is a link to the actual final code in KDAlgorithms. It has support for perfect forwarding and for perfect return, which this solution is lacking. But go over there and give me your angry feedback if there's something I'm missing over there, or even better, give me a patch that solves the problem. That's it for this week's episode of Qt Widgets and more. Thank you very much, and until we see each other next time, have a great time.